Let's say the population of Australia is reported in a newspaper as 23 million. Is this an accurate number? Logic would tell most people no, of course there isn't exactly 23 million people in Australia, so the number is not very accurate. However, as scientists or mathematicians, we have a particular way of measuring how accurate a number is. We figure out how many significant figures are in the number. The more significant figures a number has, the more accurate it is. But how do you figure out how many significant figures a number has? Well, let's work through a few examples. We'll start with the number 23 million. Now, the first and easiest rule relating to significant figures is that any number that is not a zero is significant. So in this case, 2 and 3 are significant. When it comes to zeros, however, there are 3 rules to remember. The first is that trailing zeros, which are zeros at the end of a number, are only significant if there is a decimal point in the number. And as you can see, there is no decimal point in this number, so the trailing zeros are not significant. So this number, 23 million, has 2 significant figures. In other words, it's not very accurate. Let's try another example, 1 million. We know that all non-zero numbers are significant, so the 1 is significant. We also know that trailing zeros are only significant if there's a decimal point shown in the number. There's no decimal point, so these trailing zeros are not significant. So the number 1 million has 1 significant figure. But what if we had the number 1,000,000.0? The 1 is of course significant, and in this case there is a decimal point shown in the number. According to our trailing zeros rule, these zeros therefore count as significant. So the number 1,000,000.0 has 8 significant figures. It's much more accurate. This number has been measured very carefully to 1,000,000.0. Now what about the number 2007? The 2 and the 7 are both significant, but the zeros in this case are not trailing zeros. They don't follow the last non-zero number. They're actually captive zeros between 2 numbers. And the rule for captive zeros is that they are always significant. So the number 2007 has 4 significant figures. Now let's consider 0.007. The 7 is significant because non-zero numbers always are. The zeros, however, are in front of the number. They are leading zeros. The rule for leading zeros is that they are never significant, even if there is a decimal point. So we've learnt about non-zero numbers and trailing, captive and leading zeros. Let's try a more complicated example, such as 0.0306040. The 3, 6 and 4 are all significant. That's easy. The first 2 zeros are leading. They're never significant. The zeros between the 3, 6 and 4 are captive, and captive zeros are always significant. And the last zero, the trailing zero, well, it's only significant if there's a decimal point in the number, which there is. So this number has 6 significant figures. Now it's your turn. Pause the video here and see if you can work out how many significant figures these 2 numbers have. Okay, in the first number, 7, 7 and 9 are all significant. The leading zeros are not significant. The captive zero is significant. And the trailing zeros are significant because there's a decimal point in the number. So 0.0770900 has 6 significant figures. Great work if you had 6 as your answer. In the second number, 1, 6, 4 and 1 are all significant. The captive zero is significant, and in this case, because there's no decimal point, the trailing zero is not significant. Therefore, this number has 5 significant figures. Well done if you got the correct answer. Remember that practice often makes perfect, so keep doing practice exercises to revise, and you should be an expert in significant figures in no time.